Hello, I'm Jorge Gallego from Odin Solutions. We are here in the UPV. We are working on the open call from IMAGINE-B5G. We are in charge of the SMATRA-5G project or solution, and we have come here today to do one of our trials with the robot that the UPV team has. And well, our project is based on the use of digital twins to enhance the data processing and the latency access time during the development of the digital twin of vehicles. And in the following, you will see our trial here together with some photos and some statistics. Thank you very much.
Here you can see the UPV robot across their facilities. Inside the robot there is an OBU that is running our client that is constantly monitoring, as you can see in the screen, the speed of the vehicle. On the mech, in each one of the G-Node bits, we have two different mechs, in which in the first one we initially have a digital twin of the vehicle, in this case the robot, and when this robot crossing the UPV facilities is doing a handover between the two different cells, it automatically triggers a migration of the digital twin from one mech closest to the first G-Node B to the second one, the target of this handover. In this way, what we have is that a SMATRA-5G solution provides this seamless transition of the digital twin between the two virtualization domains, so we can have a seamless experience, and the external consumer observing this data will not be aware of this movement. Meanwhile, we will maintain some robustness of the data freshness, and also the system will be performing at an optimal level all the time. Here you can see the internal debug option of our solution. On the left, you will see that the application is monitoring the current serving cell through the CAPIF, although you can see some errors from the debug. Now it detected the handover and it asked for a new virtual OBU in the new location, and in a few seconds it will be ready, and the system keep working with the new digital twin located in the second cell, as we mentioned earlier. On the right, although it went a little bit crazy because of the this is the internal debug view, you can see the external consumer that didn't stop receiving the data constantly, thanks to this seamless transition between the two nodes. Here in the internal panel, you can see the speed of the robot that is constantly being monitored through the SMATRA-5G or the virtual OBU solution. Also, we see the latencies of the access to the data, and on the low section of the screen, and in the top section of the screen you can see some information from past experiments with it, and on the right side you can see this transition between two cells and the system working perfectly. All the data is being monitored, and the experiment was successful. So with SMATRA-5G, we leverage all the capabilities that the platform of IMAGINE-B5G and the facilities of the UPV provided us to showcase a use case in the vertical of the transports and logistics. And we were able to easily integrate our application within a real Beyond 5G infrastructure in almost no time.